Go. Okay, on this first one, I would like to get a volunteer who's willing to tell me what they think it is after it's multiplied out. Take it, it's easy. Say it's an easy one. Somebody knock down an easy one. What do you say?
3x minus 5.
Yep, tell me what you get.
12x squared.
You are so right. Now, some people say, but Mr. Silver, you said if you can factor it, you should. Well, but the problem is you'll get the original problem back again, and then that'd be kind of dumb, right? So this is the final answer. Okay, on to the next one. If you multiply this out, it's just FOIL. First outside, inside, last. X squared, and the outside's negative 5x, inside's positive 3x, negative 2x, and the last make negative 15. By the way, so far, you've already seen me take something that was in factored form and put it in general form. This is also factored. It's a little weirder, but it's factored, and it's made into general form. Do you get the idea? We are changing from vertex form to general form is the goal for today. But so far, all we've done is change it from factored form to general form. This is factored. This is general. General means you have an A term, in this case 1, a B term, and a C term. That's general form. Okay, the next one. This one's weird because the outside and inside cancel, and it's just x squared minus 49. That one is called vertex form. It was factored form. This one's called vertex form. Why? Because if I just rewrite it a little bit, I bet you can tell me, without thinking too hard, this one's vertex. Where do you think the vertex would be on this? Do you remember this from algebra? Maybe you don't. All right, well, here's where you find the vertex. It's these two numbers, 0, negative 49. Because vertex form is obviously meant to give you the vertex. Factored form is obviously meant to give you the factors. That and that are the factors. As in you multiply them, you get the answer. General form is what you get when you multiply. So I usually say, if you want general form, generally, just multiply your problem out. Like that or that, you just generally multiply them out, and you get general form. Here's A, here's B, and this one doesn't have a C because there's a plus 0 at the end. So you could say that the C term is 0. All right, so there's a quick overview of the kinds of options you have for these quadratics. These are both quadratics. One of them might be stretched more than the other, but do you remember stretch factors? Okay, one of them's flipped upside down. How does that happen? A negative. The negative out in front makes it upside down. This is a normal one. That's how they start, and there should be a little arrow on the end there. And this should be a little arrow there, negative out in front on it. So it would be like y equals negative blah, 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 blah. Has to have an x squared in it. All right, so they generally look like that. General form, always, here's an example. It's all multiplied out. Vertex form, here's an example. And what would the vertex on that guy be? You would think it's negative 3,7, but it's not. It's 3,7. The other one was a bad example because it was a 0, and you can't have a positive or a negative on a 0, right? But in this case, we have a negative in here. Why do you think it changes to a positive? Can't trust anything on the inside. That's a good rule to follow. Yep. It's negative 3, but it's actually positive 3,7. All right, and then there's last form. It's called factored form. You take any equation that'll actually factor, like let's say this one, and we factor it out. Let's say we had, actually that one won't factor, but I'm going to just take a different one and write it in factored form. That is written in factored form. Now, last thing you need to know is what are they good for? Why do you have all these different forms? Why can't we just have them in one form? Why, this is the form that you learned a long time ago. Why can't we just go with that? Because factored form gives you the roots, the zeros, the x-intercepts, this form right here. It's got the x-intercepts just sitting right there. If you need the x-intercepts for some problem, that's the form to use because they're just sitting there, negative 5 and positive 4. Does that ring a bell? You remember solving those in the top 20? Okay, so this kind is good because it gives you the x-intercepts, also known, aka, as the roots, zeros, and solutions. So that's what factored form is good for. Vertex form is good for the vertex. And lastly, general form is this guy. And besides being ready to give me A, B, and C, which are then handy to use in the quadratic formula, the other thing that general form is good for is that right there on the end of it, something's just sticking out, and that is the what? The y-intercept. Fill in this sentence. The y-intercept is where what? Nope, false. X equals 0. There we go. Y-intercept is where x equals 0, and the x-intercept is where? Y equals 0. Okay, good. So if you want to know which one of these is best for y-intercept, if the y-intercept is where x is 0, do you get how putting a 0 here and here just makes them disappear? That's why it's so good for telling you the y-intercept. As opposed to the y-intercept here is where x equals 0, but now I got to actually solve a math problem. I can still get it, but it's more complicated. On this one, if I put in a 0 here and here, again, it doesn't just like all disappear. It changes into 5 times -4. I can still find it fairly quickly, but the easiest one, that guy tells you the y-intercept the best. This guy tells you the vertex the best. And this kind, factored form, tells you the factors, of course, but those are the roots, the zeros, the solutions, these numbers that you put in like -5 and +4. Those numbers are really handy. All right, so if you had this equation, do you get that it would touch as a parabola like this, and what would this spot be and that spot be? Think about it. -4 and what? +5. Do you get where I just got those from? Okay. And how come it's not upside down making a mountain shape? Because there's no negative. If there had been a negative in the front, then what would happen? It would just flip. It would still go through these two spots, but it would go like that. Does that make sense to you? All right, what form is that in? Factored form. If I multiply it all the way out, it'll be in general form. So to get general form, generally, you just have to multiply it all the way out. And the title of the lesson for today was changing, there it is over on the screen that people at home can't see, but we can see in class, to be able to change from vertex form to general form. Here's vertex form. How do I change that to general form? I generally just multiply it out. So tell me what I do wrong when I do this. X squared minus 9 plus 10. X squared plus 1. You wouldn't believe how many times I see that. Yes, sir. What I did was square both of them and got this. What's wrong with that? So what should I have done? X minus 3, x minus 3, and that makes x squared minus 6x plus 9. So if I'd have just thrown in a little minus 6x right here, then it would have been all okay. And then I have to just put things together like the -9 and the plus 10 makes plus 1. So then I'd still need a minus 6x. Oh, you're right. That's a +9, not a -9. Good point. Thank you. And so then that +9 and then the +10 makes +19. And there is my right final answer. I'll give you another one that's a little cleaner. Everybody try this one. Remember, don't fall into the trap of thinking, oh, x squared plus 49. No, it's not. Pause for a second while you try this one. I would like you to compare. I'll set you up with people to compare with. Okay, I'm back with you. So we're going to say y equals x plus 7 and x plus 7 and then minus the 10. It's just always best to write it all out and then show your work because you won't make little mistakes as often. So then the first outside inside last, x squared plus 7x plus another 7x plus 49 minus 10. And then I summarize it all up with x squared plus 14x plus 39. Raise your hand if you had the same thing as I did. Okay, awesome. That was taking it from what form? Vertex to what form? General. What's vertex good for again? Duh. The vertex. And how about general? It's a little more obscure. the y-intercept. The y-intercept on that is 39. It also is good for saying those three things, which are called A, B, and C, and they go into the what? Quadratic formula. That's what's also handy about this form. What number is here if there is no number there? That's a 1. So 1 is the A, 14 is the B, and 39 is the C. You can use that to do the quadratic formula, which finds you the roots. I know the vertex of this is 7 comma negative 10. True or false? Why false? Negative 7 comma 10. Good. I always try to practice those common mistakes with you to keep you from making them. All right. So your homework, I've talked about it enough here that I think you can do everything except maybe one thing. Maximums and minimums, I think they're pretty obvious, but I sometimes get proven wrong. So is that going to have a minimum or a maximum point? That's going to have a minimum. Very good. And this kind has a maximum. Okay, good. And that spot is the vertex. You get that? Wherever the minimum or maximum is a vertex. Okay, last thought. F of negative 2. Did they just tell me x or y is negative 2? X is negative 2. And then whatever it equals is the y. But the x is negative 2. So I take negative 2 and I stick it in right there, and I can solve the problem from there and find out what the y is. Any other last things you need to know? All right, this is a short lesson because this isn't super tough stuff. Your assignment is just as you would see it, and I'm giving you the whole thing. The one thing I'll warn you about, this doesn't work on iPads terribly well just because it's kind of a longish assignment, so you got to do a lot of scrolling up and down. If you want to do it on paper and have your iPad be the problem and you write your answer on paper, I'm fine with that. Why don't you look at it and just judge. Either way, you got to call it up on your iPad, so judge whether or not it's going to be too much of a pain to write it out. And if so, you can do it on your own separate sheet of paper. Okay, in the rest of the hour today, I will be collecting projects. And so that's all I have for the video for today.